The replacement bolts still have not arrived, and every convoy expects this bridge to remain open. I tighten one more temporary fitting and record every change exactly as it is. The structure still holds, but I can feel the weight asking more of it each day. Before dawn comes, I have to trust a decision that was never meant to last. The first signs of failure did not come with explosions or collapsing steel. They appeared months earlier in the quiet routine of wartime construction, hidden inside maintenance reports, supply shortages, and practical decisions made under relentless pressure. Somewhere in occupied Europe, before dawn on a cold spring morning, a military bridge that had carried hundreds of vehicles without incident became unexpectedly vulnerable. The weakness was not the result of sabotage or enemy brilliance. It traced back to a small shortcut taken by an engineer whose responsibility was to keep traffic moving despite impossible demands. His name rarely appeared in official histories, yet his decision became part of a chain of events that revealed how ordinary compromises could shape extraordinary consequences. By the beginning of 1944, military engineers across Europe worked under conditions that rewarded speed as much as precision. Every bridge, road, and rail junction carried strategic importance. Armies depended upon uninterrupted movement of fuel, ammunition, food, medical supplies, and reinforcements. Delays measured in hours could influence operations scheduled weeks in advance. The burden fell heavily upon engineer units, whose work was rarely dramatic but constantly essential. Their days began before sunrise and often ended long after darkness had settled across construction sites illuminated only by shielded lamps. Materials arrived late. Replacement parts frequently failed to appear at all. Equipment operated well beyond recommended service limits because there was simply nothing else available. Among these engineers was Sergeant Arthur Bennett, a civil engineer before the war whose civilian experience had led to assignment within a British Royal Engineers construction company attached to logistical operations supporting preparations for the coming campaigns in Western Europe. Bennett was not a bridge designer in the academic sense. His wartime responsibility centered upon inspection, maintenance, reinforcement, and rapid repair of military transport crossings constructed from standardized components. Every structure carried an inspection schedule. Every damaged beam required documentation. Every unusual vibration, crack, or shifting support demanded evaluation. His reports earned respect because they were concise and practical. Senior officers knew he avoided exaggeration while refusing to overlook genuine problems. Fellow engineers trusted his measurements because they matched what they observed in the field. Yet by March 1944, even experienced men found themselves confronting shortages unlike those faced earlier in the war. Steel components intended for maintenance increasingly went toward new construction projects judged more urgent. Timber shipments arrived behind schedule after railway congestion delayed transport across Britain. Specialized bolts manufactured to strict engineering tolerances became difficult to replace as factories shifted production priorities. The bridge under Bennett's supervision crossed a modest river near an important military supply route serving several embarkation areas where vehicles assembled before movement towards southern England. Although temporary by peacetime standards, the bridge carried a remarkable volume of wartime traffic. Heavy lorries crossed throughout the day. Fuel tankers passed in carefully controlled intervals. Tracked recovery vehicles occasionally rumbled across despite weight restrictions. Ambulances, motorcycles, bicycles, and marching troops shared the crossing according to detailed movement schedules. The bridge had originally been designed with conservative safety margins. However, wartime usage steadily eroded those margins. Repeated inspections revealed increasing wear around several bearing plates supporting one section of the central span. Under ordinary circumstances, Bennett would have ordered complete replacement of the affected fittings. Unfortunately, replacement assemblies remained unavailable despite repeated requests. Temporary reinforcement remained possible. The official procedure required installation of additional steel plates secured by approved high-strength bolts manufactured for structural applications. Those bolts had not arrived. Instead, Bennett faced growing pressure from movement control officers who warned that closing the bridge, even briefly, would force lengthy detours disrupting carefully coordinated transportation schedules. No senior officer directly instructed him to ignore regulations. Instead, conversations focused upon practical necessity. Could repairs wait another week? Could inspections become more frequent? Could traffic be managed differently? Could temporary measures preserve operations until proper materials appeared? Such questions became increasingly common across engineer units struggling against shortages. Bennett examined the bridge repeatedly over several evenings. Measurements showed gradual deterioration rather than sudden failure. Calculations suggested additional reinforcement remained desirable but not immediately critical if load stayed within specified limits. The difficulty lay in maintaining those limits. Drivers rarely knew precise vehicle weights after additional cargo had been loaded elsewhere. Convoys sometimes combined vehicles beyond planned spacing during periods of darkness or poor weather. Emergency movements occasionally ignored ordinary restrictions altogether. Bennett finally authorized what engineering documents described simply as a temporary field modification. Instead of approved structural bolts unavailable through supply channels, he used slightly smaller fasteners intended for heavy machinery maintenance. Additional locking plates compensated for dimensional differences, while careful torque measurements ensured secure installation. The modification complied with neither original specifications nor preferred engineering practice. However, calculations suggested sufficient strength for limited service until proper components arrived. Bennett documented every alteration. His maintenance log specifically identified the temporary installation, requested priority replacement materials once again, and recommended continued monitoring. The paperwork moved upward through administrative channels already overwhelmed by thousands of similar requests. Spring weather complicated everything further. Repeated rain softened embankments supporting approach roads. Heavy traffic compressed foundations beneath temporary surfaces. Engineer units divided their attention among countless urgent repairs spread across expanding logistical networks. Inspections continued. The bridge remained stable. Traffic never stopped. Each successful crossing quietly reinforced confidence that the temporary repair would survive until permanent maintenance became possible. During April, movement intensified. Preparations connected with future operations demanded enormous transportation effort. Supply depots expanded. Vehicle parks filled with equipment awaiting deployment. Engineer companies built additional storage areas while maintaining existing infrastructure already operating near maximum capacity. Night movements became especially frequent. Darkness reduced vulnerability to aerial observation while allowing convoys to reposition without disrupting daytime construction work. Drivers followed blackout regulations limiting visibility to narrow beams carefully shielded from distant observation. Marshals directed traffic using covered lamps and hand signals. Engineers inspected bridges whenever brief opportunities appeared between vehicle columns. Bennett noticed subtle changes. One reinforced connection displayed slightly greater movement under heavy loads than measurements taken 2 weeks earlier. The difference remained within acceptable temporary limits but suggested growing fatigue. Another request for replacement hardware entered official records. Again, no delivery followed. By early May, intelligence reports warned of increased enemy reconnaissance directed toward transportation infrastructure throughout occupied Europe and southern England alike. Railways, bridges, fuel depots, and road junctions represented obvious targets because they supported anticipated military operations. Camouflage received renewed attention. Anti-aircraft defenses increased around key facilities. Bridge guards strengthened observation routines. Engineer detachments prepared demolition charges for emergency denial should enemy breakthroughs threaten important crossings. The bridge itself attracted little attention beyond local responsibility. Its modest appearance concealed its logistical importance. Unlike famous river crossings celebrated in military histories, this structure simply carried traffic efficiently day after day. Before dawn on a cloudy morning, several weeks after Bennett's temporary repair, movement orders scheduled successive convoys carrying engineering equipment, fuel, and bridging materials toward assembly areas. The timetable allowed little margin. Delays at one crossing quickly affected routes extending many miles. Around first light, observers reported aircraft approaching at medium altitude. Air raid warnings sounded across nearby installations. Drivers halted where possible. Some vehicles continued toward designated dispersal points rather than stopping upon exposed roadways. The bridge remained occupied by several heavy lorries separated according to standing instructions. Enemy aircraft, likely conducting armed reconnaissance while searching for transportation targets, descended through scattered cloud. Their attack focused not upon the bridge alone but upon the surrounding road network. Bombs fell across nearby fields, intersections, and embankments. Machine gun fire swept stretches of roadway crowded with halted vehicles. One explosion landed near the western approach. The blast did not strike the bridge directly. Instead, it displaced earth beneath part of the supporting embankment while shock waves traveled through already stressed structural members. Almost immediately, engineers noticed unusual movement within the central span. The temporary reinforcement remained intact. However, adjacent original components, already weakened by months of heavy service, shifted beyond expected tolerances. The bridge had not collapsed. Neither had it remained fully reliable. Bennett reached the site within minutes, accompanied by another inspection team. Ignoring continuing danger from possible renewed attack, they crawled beneath the structure carrying measuring equipment, notebooks, and portable lamps. Traffic halted completely. Vehicles accumulated rapidly along both approaches. Movement control officers demanded immediate assessment. Could the bridge remain open? Would repairs require hours or days? Was complete replacement necessary? Bennett refused to answer until inspections finished. His measurements confirmed the worst possibility. The shortcut itself had not failed. The smaller bolts still held securely. Instead, the altered stress distribution combined with blast damage had accelerated fatigue in neighboring components originally expected to share different loading patterns. The temporary repair had successfully preserved one weakness while unintentionally transferring greater strain elsewhere. Engineers often recognized such risks. Normally, permanent replacement followed before secondary effects developed. In this case, operational pressure had extended temporary conditions beyond their intended duration. Bennett recommended immediate closure. The decision disrupted scheduled movements throughout the region. Recovery vehicles established alternate routes. Pontoon bridge sections stored nearby moved toward the river. Additional engineer companies arrived carrying timber, steel panels, hydraulic jacks, and lifting equipment. Throughout the day, Bennett coordinated inspections while documenting every measurement. His reports carefully distinguished confirmed damage from preliminary observations. He neither concealed nor exaggerated the consequences of his earlier decision. When questioned by superior officers, he presented maintenance records showing repeated requests for approved replacement hardware. Every recommendation appeared in chronological order. Every inspection remained documented. Every temporary measure carried appropriate notation. The paperwork demonstrated neither negligence nor perfection. Instead, it revealed an engineer attempting to balance regulations against operational necessity within a strained logistical system. The bridge reopened after extensive reinforcements several days later. Permanent structural members replaced temporary modifications. Approach embankments received additional stabilization. Traffic resumed under revised weight controls. The interruption proved inconvenient rather than catastrophic because alternate crossings and rapid engineer response prevented complete logistical paralysis. Nevertheless, the incident prompted wider review. Engineer headquarters examined maintenance procedures governing temporary structural repairs throughout transportation networks. Inspection intervals shortened for bridges experiencing unusually heavy usage. Supply priorities shifted modestly toward replacement hardware previously considered routine. Administrative guidance emphasized that temporary field modifications required renewed evaluation whenever operational conditions changed significantly. These adjustments reflected lessons learned not from spectacular destruction but from careful examination of an avoidable vulnerability. Bennett expected disciplinary action. Instead, he received formal questioning followed by reassignment to infrastructure assessment work supporting subsequent operations after Allied forces established positions on the European mainland. His practical experience with overstressed bridges became valuable precisely because he understood how ordinary maintenance decisions accumulated under wartime pressure. Later reports described him as methodical, cautious, and unusually thorough in documenting structural conditions. Colleagues remembered that after the incident he rarely accepted temporary solutions without attaching explicit expiration dates and repeated follow-up inspections. Younger engineers occasionally considered his caution excessive until circumstances reminded them how quickly wartime demands could transform acceptable compromises into hidden hazards. Official histories devoted little space to such episodes. Campaign narratives naturally emphasized battles, commanders, and major offensives rather than maintenance records or engineering memoranda. Yet surviving wartime documents reveal that transportation infrastructure required continuous judgment by individuals whose names seldom reached newspapers. Bridges did not simply exist. They endured through inspection, repair, calculation, and constant adaptation to burdens exceeding original expectations. The bridge that became vulnerable at dawn remained in service long enough to support continuing military operations after proper reinforcement restored its full strength. Travelers crossing the river months later would have noticed little beyond ordinary military traffic moving steadily toward distant fronts. Few would have realized that beneath the steel decking lay evidence of an engineer's difficult choice preserved within replacement components and archived maintenance reports. Arthur Bennett returned to civilian engineering after the war, carrying with him lessons unlikely to appear in medals or public ceremonies. His experience demonstrated that responsibility during wartime often rested not upon dramatic acts of heroism but upon countless technical decisions made with incomplete information, limited resources, and unrelenting deadlines. His small shortcut did not define his career. Rather, the honesty with which he documented it, accepted scrutiny, and helped improve future engineering practice became the quieter measure of his service, reminding later generations that the strength of military operations depended as much upon careful maintenance and professional accountability as upon the courage displayed on the battlefield.